Good day viewers and welcome to my channel. Today we are going to be looking at the 2022 Chemistry Neco volumetric analysis. And we are going to read out first the instruction that was given for the preparation of the reagents. Here we have 150 cm cube of triazonitrate 5 acid solution in a bottle labeled AN. The acid solution, which should be the same for all candidates, will contain 9.50 cm cube of concentrated triazonitrate 5 acid per dm cube of solution. Then for the triazocarbonate 4, we have that 150 cm cube of sodium triazocarbonate 4 solution in a bottle labeled BN. The solution, which should be the same for all candidates, will contain 4.20 gram of sodium triazocarbonate 4 per dm cube of solution. So for this preparation, we require sodium triazocarbonate 4, triazonitrate 5 acid, electronic balance, watch glass, measuring cylinder, volumetric flask, 2 volumetric flasks of 1000 ml, and distilled water. So from our instruction, we are going to measure 9.5 cm cube of this nitric acid, and then we are going to transfer it to our volumetric flask. But before that, we are going to transfer 500 cm cube of distilled water to our volumetric flask. So I'll transfer a little of my acid. Please, when preparing your reagents and you are using acid, make sure you use hand gloves. So I will measure out 9.5 cm cube of this acid using this measuring cylinder. Okay, I have here 9.5 cm cube of my triazonitrate 5 acid. So I'll transfer the 9.5 cm cube of the acid into the volumetric flask. And I will top it up to the 1000 cm cube mark with distilled water. So this is 1 dm cube. So here I have 9.5 cm cube of my triisonitrate 5 in 1 dm cube. I'm going to prepare the sodium triisocarbonate 4. According to the instruction, we have 150 cm cube of sodium triisocarbonate 4 solution in a bottle labeled BN. The solution, which should be the same for all candidates, will contain 4.20 grams of sodium triisocarbonate 4 per dm cube of solution. So I'm going to measure out 4.2 grams of this sodium triisocarbonate 4. Firstly, I'm going to transfer a little water, a little of my distilled water, maybe about 250 cm cube or thereabout. So I've transferred some of my distilled water to the volumetric flask. Then I'm going to measure out 4.2 grams using my electronic balance. I'll measure out 4.2 grams of this sodium triisocarbonate 4. Measure out. Okay. So we have weighed out our 4.2 grams of sodium triisocarbonate 4, and we are going to transfer the 4.2 grams into this beaker, and we are going to dissolve it in distilled water. Always make sure when you are weighing with the electronic balance and you are using maybe a watch glass or petri dish to measure, always make sure you measure your petri dish or your watch glass first and write down the weight. Then you add what you want to measure, weigh and write down the weight so that you can be able to minus the weight of the watch glass, and then you get the actual weight of what you are measuring. So I'm going to dissolve this in distilled water. And then I'll transfer to the volumetric flask. Okay, then I'll top it up to the 1000 cm with distilled water. Okay, I'm almost there. I have to remove my funnel and carefully okay, so I have my 1000 cm cube, that's my 1 dm cube. So now see that I have my 9.5 grams of my triisonitrate 5 acid in 1 dm cube here, and I have my 4.2 grams of sodium triisocarbonate 4 in 1 dm cube. You are ready for the titration. So I'm going to now transfer. Okay, so now I'm going to transfer 150 cm cube of my triisonitrifide acid to my beaker, and I'm also going to transfer 150 cm cube of my sodium triisocarbonate 4 to another beaker labeled B. And then we are ready for this titration. For this titration, we are going to be using the indicator methyl orange. So I require a funnel. I'm going to be using a 250 ml pipette, a 50 ml burette, and then a conical flask. So I transfer my A to my burette. Make sure that the tap is locked. So I'm beginning my titration from the 0 mark. You always take your reading from the lower meniscus. When you are taking readings from the burette, always make sure you read from the lower meniscus to avoid error due to parallax. So I'll rinse my conical flask with distilled water. Add 2 to 3 drops of methyl orange indicator. So we'll begin our titration. And see the color has changed. You notice that for this first titration, my eye was on the conical flask and not on the burette. When you are performing rough titrations, your eye should be more on your conical flask so that you can easily detect the endpoint. So from that, you can now know when you are getting close to the endpoint for subsequent titrations. Bring the camera close so that we can take the reading on our burette. So you see, our reading is 13.9. So we'll take. So I'll transfer to the conical flask and add 2 drops or 3 drops of my methyl orange indicator. I added 2 drops of methyl orange indicator. Now I'm going to swirl and titrate. So I'm beginning this first titration from the 0 mark. Since I already have an idea of my rough titration, I got 13.90. So when I'm getting close to 13, I'll now start, reducing the speed of my start. So I start my titration. This time around, my focus is on the burette. So as I get closer to 13, I reduce the speed. This and make it to drop in a dropwise manner, and that is the end point. So bring the camera closer. And from what I have here, have about 13.6. Have about 13.6 as my endpoint. So these are table of values for the rough first, second, and third titrations, and our average volume of acid used is 13.53 cm3. The volume of pipette used for this titration is 25 cm3, and the indicator used is methyl orange. Don't forget to subscribe.